So we're continuing to work through the rational roots theorem, and we're going to include now the conjugates theorem. So we're going to utilize the rational roots to find all the solutions for this polynomial equation, and we're also going to have to utilize the conjugates theorems when finding some of those solutions or zeros to this equation. So first thing you want to do is identify information based off of your first term and last term. You want to identify your lead coefficient. In this case, it's 1. You want to identify your constant, which is right here, which is -3. And your degree, which is also 3 in this case. So we know that we are looking for 3 solutions or 3 zeros, which will make 3 factors, and they will be based off of a lead coefficient of 1 and a constant of -3. So, because I'm told specifically to use the rational roots theorem, I'm going to use that 4-step process. So, step 1. Step 1, we're going to list possible rational roots. We list our possible rational roots based off the rational root theorem of plus or minus p over q, which are your factors of constant, in this case of 3, all over your factors of your lead coefficient, which in this case is 1. So, nice, small, easy set. So 3, I have factors 1 and 3, and lead coefficient, I have 1. So a super small set. I have positive or -1 and positive or -3. Right, so here's my list. Easy. Right, step 2. Use that list and test it. So step 2, test for zeros. We test for zeros using synthetic division. Right, testing for zeros using synthetic division. So we're going to use synthetic division, and if your remainder is 0, you have found a 0. Therefore, you can create a factor. You found one of the solutions to that equation. So we are going to start with positive 1 and -1. So 1, -1. Right, and we need to look up at our original function, and we have coefficients of 1, positive 1, -3, -3. So 1, positive 1, -3, -3. I'm going to use the synthetic process to see if I can find a 0. Synthetic division, you bring down your first term and then multiply and combine. So 1 times 1 is 1, combined together is 2. 1 times 2 is 2, combined with -3 is -1. 1 times -1 is -1. Combine those together, I get -4. Is that a 0? No. Right? So let's see when x equals -1. Bring down your 1. -1 times 1 is -1. That causes a 0. -1 times 0 is 0. -3 combined with 0 is -3. -1 times -3 is a positive 3. And -3 and 3 combine to make a 0. And you rejoice. Woo! So, we have found a 0. So now we need to rewrite what that information tells us. So step 3. Rewrite in factored form. So we're going to use that synthetic information to write out that exact same function, but in factored form. So, since we found this x gave us a 0, when x equals -1, you have a factor of x plus 1. When you have a synthetic quotient of 1, 0, -3, we started with x cubed, so this creates 1x squared plus 0x minus 3. So together they create a factored form of that function of f of x equals x plus 1 times x squared minus 3. Alright, once we are in factored form, we have a fourth step. So step 4, you're asking yourself a question: can I factor more? It's a rhyme. So step 4, can I factor more? Alright, so we look at that and I go, okay, looking at what I have, can I continue to factor that? So the x plus 1 cannot factor anymore. It is a binomial. It's done. But that x squared minus 3, we can factor because there are two x's multiplying in there. We have a couple things that we can use. If you know the difference of squares, you may be able to use it. Ooh, except the 3 is not a square, so can't use that. Alright, we can use the quadratic formula. We'll have a 0 for our b value, so you can always do that. But you should remember when we were factoring before or finding zeros and finding solutions, you can actually set that term to 0. So we are going to keep the x plus 1, and we need to set that x squared minus 3 to 0 to find the solutions. So you have a couple different choices, but if you're just left with a binomial with an x squared, you know how to use square roots to solve by now, so you can do that. So let's take that. X squared minus 3 equals 0. So we have x squared equals positive 3, or x equals plus or minus root 3. This is where that conjugates theorem comes in play. Right? We have two solutions, a positive root 3 and a negative root 3. So those create factors of x minus root 3 and x plus root 3. Right? So we have a final solution now. We have the first x. Right? So solutions. We have that first x that we found of -1. We found a positive root 3 and a negative root 3. Those follow our conjugate theorems, that if you have a positive irrational, you also have a 0 at the negative of that same irrational. If we look at our original, we have third degree because of that x cubed, so we were looking for 3 zeros. We found 3 zeros.